So today I am going to discuss the Leet code problem number 416, partition equal subset sum. So in this problem, you are given an array and you need to return true if you can partition this array into two subsets whose sum is equal. So here I can partition this array into the subset 1, 5, 5 and 11. And the sum of both of the subset is equal, which is 11. Okay. So let's see how we can do that. 1, 5, 11, and 5. Let's do that. Okay. So we are given an array 1, 5, 11, and 5. Now I need to return true if this array can be partitioned into two subsets whose sum is equal, and otherwise I need to return false. Okay. So what is the obvious thing that I can do? Okay, so first of all, what I can do is I need to find out whether it is possible to partition this array into two subsets whose sum is equal. Now think of it that if you have two subsets, right, and whose sum is equal, right? So if the two subsets sum is, let's say, an even number, 6 and 6, which is equal to 12. If the two subsets sum, one subset sum is 5, another is 5, and if you sum that, then that's 10, right? So that means what it means is when you add all this array element, the sum should be even. And we can partition this array into the two subsets only if the sum of this array is even. Otherwise, we cannot, okay? So what I'm going to do is I'm going to find the sum. 1 plus 5 plus 11 plus 5, which is equal to 16, 26, right? Now I got sum even, right? 26 is an even number. So that means I can partition this array into two subsets. Now I need to find out whether I can do it or not, whether I can partition this into two subsets whose sum is equal. Now looking at this array, you can create one subset with 1, 5, 5 and another subset with 11, and both of this subset, this has sum 11 and this has sum 11. So the answer is true. We can do that, but let's see how we can do that. Okay. So one thing is, if I get this sum even, then what I need to do is I need to find the subset, all the subset for this array. So what are all the subset for this array? Empty subset. So here, I think they have a constraint that the subset cannot be empty. Let's see. Do they have a constraint? If you can partition the array into two subsets, it says, okay, it can be empty also. Let's find all the subsets. One is empty, one is 1, 5, 11, 1, 5, 1, 5, 11, 5, 11, 1, 11, 1, 5, 11, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are more subsets. 1, 5, 11, 1, 5, 1, 5, 11, then 1, 5, 5, 10, 11, 1, 11, then we have 5, 5, then we have 11, 5, 5, and then we have, did I miss anything? 4, 5, 6, 7, 8, I think I didn't miss anything. So looking at this, all the subset, if you see, so this subset and this subset, they have equal sum, right? So the answer should be true. So what I need to do is first I need to find all the subset. Now, to find the subset, right, if I'm given this array, 1, 5, 11, 5, right? If I'm given this array and if I want to find the subset, what I'm going to do is I'm going to work with this index, first one, okay? Or maybe since we are doing recursively, I'll start at this index 5. Now, I have two choices, okay? First choice is I can include this 5 in my subset or I can exclude, right? These are the two options I have. Now, if I include this 5 in the subset, then I'll have this, and if I exclude 5, I'll have empty subset. Then I move on to the next element, right? 11. So when I move on to 11, again I have two options, whether to include 11 or exclude 11, right? So this is include, this is exclude. If I include 11, I have 5 and 11. If I exclude 11, I have 5. If I include 11, I have 11. If I exclude 11, I have empty. I move on to the next element, which is 5. Again, include, exclude, include, exclude, include, exclude, include, exclude. So if I include 5, then I have 5, 11, and 5. If I exclude 5, I have 5, 11. If I include, I have 5, 5. If I exclude, I have 5. If I include, I have 5, 11. If I exclude, I have 11. If I include, I have 5. If I exclude, I have empty. Right? And then I go on to 1. Same thing. 1, 2, 7, 8, 9, 10, 11, 12, 13, 15, 16. 16 subsets. 5, 11, 5, 1, include, exclude, 5, 11, 5, include, 5, 11, 1, exclude, 5, 11, include, 5, 5, 1, exclude, 5, 5, include, 5, 1, exclude, 5. For this one, include 5, 11, 1. So you got the point what I'm doing, right? So now, do we need to find all the subset? No. I think we are interested only in the subset. So if I'm given this, what I need to do is this 26, I'll divide this so this is 26, 11 plus 11. Oh, sorry, this is 22. It's not 26. I made mistake. This is 22. 22, okay? So now, if I divide 22 by 2, because I need to find the two subset whose sum is equal. So 22 divided by 2 is 11. So I need to find a subset whose sum is 11. If I can find a subset whose sum is 11, then there has to be another subset whose sum will also be 11 because those are the remaining elements. So if I can find this one subset whose sum is 11, then the remaining element will form another subset with a sum 11, right? So I don't need to find all the subsets. So I need to find the subset whose target sum is 11, okay? So that's what I need to do. So here I found all the subset include exclude. No, but here now I need to add a condition that I need to find a subset whose target is what? 11, okay? So now I have this 1, 5, 11 and 5, and I'm also given my target. Let me do this. Let me change the color. Okay, so now my target is 11. So I need to find the subset whose sum is 11. So now here I'm going to start with this first element 5. So I'm going to include and exclude, right? If I include this 5, what happens to my target? I need to subtract this 5 from the target, right? So now the target remaining will be equal to 11 minus 5, which is 6. And if I exclude, my target is still 11, right? And here my subset has 5, and here my subset is empty, right? Now I'm going to do again, now the next element is 11, right? So if I include 11, my target will be negative, right? So now I don't need to continue this cycle, right? This 5, 11, right? Because I need to find a target which is 11. So here it goes to negative, right? So I need to return, right? So here what I'm going to return is I'm going to return false. Okay, now I cannot find a subset whose target is 11 from here. So I'm going to return false from here. Okay, now here I'm not including the 11. So again, the subset is 5 and target is equal to 6 and subset is 5, right? Now here I'm going to include 11. So that means my target is equal to 0, and there you go. I found a subset whose sum is 11, so I'm going to return true here from this. Now if I don't include 11, that is exclude, my subset is empty, my target is 11, right? Right? So now let's continue. So let's continue here. So this branch is done. Okay, this one is done. Let's continue here. Now here target is 6 and my next element is what? What is my next element? 5. So I'm going to include and exclude 5. Okay, so let's do that. If I'm including 5, my target will be equal to 1. 6 minus 5 is 1. And then my subset is this, right? And if I'm excluding 5, my target is 6 and my subset is still 5, right? And here this branch is done because we got target 0. For this branch, include 5, so target is equal to 6. Exclude 5, so target is equal to 11. Now, this is 5, the subset is 5. So now if you look here, okay, if you look here, let me just change the color and show you. So if you look here, this and this problem is the same. They are overlapping subproblem. So we already know that we are doing recursion, we have overlapping subproblem. So we can do dynamic programming here. Let's continue. So here we have 1. So now our next element is 1, right? 1. Include and exclude 1. Okay. So I'm going to include 1 here. So my target is equal to 0 and my subset is 5, 5, 1, and I'm going to return true. True. And here I'm excluding 1, so my target is equal to 1, 5, 5. Now here, if you look here, there are no more elements left. After 1, our index becomes 0. We don't have any elements in the array left, right? So if that's the case, this branch is going to return false. Now there are no more elements left to include and exclude. So this is written false. So what we need to do is we need to take the OR. If any of this returns true, then we need to return true. So we need to take the OR of this include and exclude, and we need to return true here at our parent branch. So here we're going to return true, and here we're going to return true, and here we're going to return true, right? Because this is 551. 551 is 11, right? So we already found a subset whose sum is what? 11 in this branch. So I'm going to return true here. And if my include is true, I'm just going to do the OR with exclude. I mean, this, if this returns true, well and good. If not, then also we're going to do the OR, because we already found a subset whose sum is 11. And therefore, we're going to return true. That, yeah, it is possible to have a 2 subset whose sum is equal, which is 11, right? So how are we going to write our recursive code? Okay, let's do that. Let me do that. Now to write our recursive code, okay, let's write our recursive code. Okay, so here we will have our recursive function. Okay, so our recursive function is going to take an array, which is a nums array. It is going to take our target, right? We'll add all the elements, divide by 2. If the sum is even, we're going to divide it by 2, and that is our target. If the sum is odd, then we don't even care. We just return false, because there's no way to find the subset, to find a 2 subset having equal sum. And we will start with the last index, which is n, right? Now we have a couple of base cases, okay? The first base case is whenever the target becomes 0, okay? Whenever our target is equal to 0, we are going to return true, because we found a subset whose sum is equal to target. And when our index and when our n, that is index, let's name it as index, okay, and when our index is less than 0, that means there are no more elements left, and we're going to return, here we need to return true. We already found a subset. We're going to return false, right? And if our index is the last index, right? We are at the last element, right? Index is equal to 0. We are at the last element. Then we need to find whether nums of that last element is equal to target or not. If it's equal to target, then we're going to return true, because we found a subset whose sum is equal to target. If these are all not the case, then we're going to do what? Include and exclude, right? So our include is equal to false initially. And we're going to say when we include the element, we're going to subtract it from nums of index target minus, right? Target minus nums of index, right? When this is greater than equal to 0, then only you're going to make a recursive call, okay? If it's less than 0, then don't bother. Just have include as false because there is no way we can make target 0. So include is equal to make a recursive call nums and target, or target will be target minus nums of index, and our index will be index minus 1, right? Because we are including that element. So we need to subtract it from the target and we need to do index minus 1. And our exclude will be F. We are excluding the element, so our target is unchanged. And index minus 1. And then we're going to return the OR of include and exclude. So what is the time complexity of this solution? So we have our tree where we are doing include, exclude, and we are stopping our recursion if the target goes negative, or if we are done with all the array elements and we don't have any more to include, exclude, right? We are returning false in those cases. But our branching factor is 2. What is the height of a tree? I mean, in worst case, we are doing target minus nums of whatever the index. So in worst case, if the numbers are 1, then we'll go 1, 1, 1, 1, 1 like that. So worst case is 2 raised to n. That is our time complexity. What is the height of a tree? I mean, what is the space complexity of n? Because that many recursive calls we are making, and we'll have that many call stack space. So our space complexity is O of n. Clearly, this is exponential, and there is a room for improvement. We have overlapping subproblem, and we also have an optimal substructure. So if we find this, in our recursion tree, if I'm finding, like for example, if I'm finding the subset whose sum is equal to 4, whether I can find a subset whose sum is equal to 4, and this returns me true, then there's no, I mean, this is the optimal answer. I mean, there is no other answer who's going to return me false then, right? So I know that I can have a subset whose target sum is 4, and there's a subset that's possible with target sum 4. If that's returned true, then yes, that's the only answer I have. So we can do dynamic programming here and improve our solution. But before we do that, let's write the recursive code for this one. Here I'm going to write a recursive code. So first of all, what we need to do is we need to find the sum of this array. So integer sum is equal to find sum nums find sum. Okay, so let's find. Okay, so once we have the sum, We are going to see whether we can partition this into the subset of sum is equal. So if sum modulo 2 is equal to 1, so if the sum is odd, then we cannot partition and we're going to return false. Otherwise, we can partition and we need to find a subset whose sum is equal to target, right? So we need to pass over nums, we need to pass over target, and we need to pass over index. Boolean, integer nums, integer target, integer index. Let's write our base case. If target is equal to 0, we got our subset of sum is equal to target, so return true. If index is less than 0, that means we are done with our element, so we're going to return false. And if target minus, now if index is 0, that is the last element, and if that last element is equal to target, then also we're going to return true. Otherwise, we're going to do our include exclude. So if we include the element, then we need to make sure that the element that we are including, which is nums of index, target minus nums of index, is greater than or equal to 0. If it's not, then include will be false. Otherwise, include will be the recursive call to this function, and then the nums, our target will be target minus nums of index, since we are including, and our index will be index minus 1. And if we exclude, then that would be nums we are excluding, so target will be unchanged, index minus 1, and we're going to return the OR of include and exclude, and that's our answer. So let's submit it and see whether it's working or not. It will time out. It's a recursive solution, exponential solution, so yes, it timed out. So now we're going to switch on to DP solution. Okay, so now let's see how we can optimize this subset sum problem. Okay, so we already saw the recursive approach. Okay, let me just write it once again. Okay, we have a function. So we have a function. That function was taking nums array. It was taking our target, the sum that we are finding, I mean the subset whose sum is equal to target. That's what we need to find. And if we can find such subset, then we return true, and the index for the array. Okay. And then we had couple of base cases, that if our target is equal to 0, that means we already found a subset whose sum is equal to target. So we return true in that case. If our index is less than 0, that means we are done with all the array element and we return false. Right? And another base case was if our index is equal to 0, that is last element. and nums of index is equal to target, then we return true, or else we do include and exclude, and we return whatever the result is for that, right? For include, we call a function with nums. We are including the element, so our target would be target minus nums of index, and then index minus 1. And for exclude, we have nums target and then index minus 1. Here we need to make sure that this is greater than or equal to 0. If it's less, then this include will be false. Okay, so that was our recursive code. Now in the DP approach, if you look at a recursive function, what are the two parameters that are changing? The target and the index, right? So we need a 2D table. What should be our table type? Since we are returning a Boolean, our table type will be Boolean, right? What is the size of the table, right? We have target and the index that is changing. So the target goes from 0 to the target. So whatever our target sum is plus 1, right? That should be the size. And our index goes from 0 to n. So we need a size of n, target plus 1 times n. That is our table size. And let's do this. So our example had 1, 5, 5, and 11, right? Our target in this case was, we had all the element 22 divided by 2, which was 11, right? And our n is equal to the size of this array, which is 4. So we are going to take a table where n is 4, which is 0, 1, 2, and 4, right? This is n, 0, 1, 2, right? And this is our target, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? Now we're going to fill in the base case. So what are our base case? So our base case was, whenever we have target is equal to 0, that means we already found a subset and we're going to return true. So here the target is 0. So true, 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 true. What was the other base case? Whenever we have index 0, right, the last element, and if that last element is equal to target, right? So let's say our target is 11. Our target is 11. Whatever our target is, for example, no, not 11. Let's say okay, so here, okay, so what is our target? 1 in this case, sorry, 1, right? Do we have nums of 0 as 1? Here nums of 0 is 1, which is equal to target, so this will be true. Then here our target is 2 is nums of 0, 2, no. So this will be false. Nums of 0 is not 3, false, 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 and false. Right? Now here, now we're gonna iterate because we're gonna iterate row by row because whatever values we need is this one, target minus something. So our target, so it's from the previous column and previous row, right? Index minus 1, right? So if we look at this cell, this one, right? So for this cell, what will be the value? So we need to do include and exclude. For include, we need to call dp. Row will be I minus 1, that is our index. We need to decrement the index, and this will be target in which minus nums of I. Okay. So here, what is nums of 1? It's 5. What is our target? Our target is 1, right? So 1 minus 5 is minus 4, which is less than 0. So include is false, right? Because this is less than 0. So include is false. What is our exclude? What is exclude? Exclude is dp of I minus 1, and the target remains unchanged because we are excluding that element. So the target here is 1. dp of I minus 1 is this, right? So here, true and false, when we OR it, the answer is true, right? Our target is 11. If we find true in this row, then we're going to return true. We are done because we have found a subset whose sum is equal to 0. Okay, at any point we find that. Okay, so now let's look here. So for this cell, right, what is our target? Our target is 2. So if we include nums of 1, which is 5 here, so target is 2, 2 minus 5 is negative, so include will be false, right? What will be the exclude? Exclude will be this value, I minus 1, and the target. So exclude is also false, so this is false, right? Let's look at this. The exclude will be this. So exclude is false. What is include? Include will be target, which is 3, minus nums of 1, which is 5, which is negative. So that is also false. Now let's look at this value, 4. So the target is 4. So when we do include, 4 minus 5, which is negative. So that is false. Exclude will use this cell, which is false. Or of that is false. Now here the target is 5. Our nums of 1 is also 5. So 5 minus 5 is 0. So we need to look at dp of I minus 1, which is a previous row, and the column 0. So include. This will be true. True, right? How about 6? 6 minus 5 is 1. So dp of 0 and 1 for include. So dp of 0 and 1 is true. So this will be true. 7 is our target. 7 minus 5 is 2. So dp of 0 and 2 is false. And the previous value is false. So this is false. 8. 8 minus 5 is 3. dp of 0, 3 is false. And exclude is this one. So false. 9 minus 5 is 4, and dp of 0, 4 is false, and exclude is this, so this is false. 10 minus 5 is 5, dp of 0, 5 is false, and this is also false for exclude, so this is false. 11 minus 5 is 6, dp of 0, 6 is false, and this is also false. So this will be false. Let's go here. Here our target is 1, num of 2 is 5, negative, but exclude. When we exclude it, it's true. So this will be true. 2 minus 5, which is minus 3, that's for include. So minus 3 is negative, so our include is false, exclude is this cell value, so this is false. 3, our target is 3, 3 minus 5 minus 2, so include is false, exclude is false, so this is false. 4 minus 5 is minus 1, include false, exclude is this cell which is false, so ORing both is false. 5 minus 5 is 0, so our target is 5 minus 5 is 0, so dp of I minus 1, which is 1 and 0, which is true. So include is true, so this will be true. 6 minus 5 is 1, and dp of I minus 1, which is 1. dp of 1, 1, we need to look at this one. dp of 1, 1, right? Because index minus 1, which is 1, so that this will be 1. Target minus nums of I, target is 6. 6 minus 5, which is 1. 1, 1, dp of 1. 1 is true, so this is true. 7 minus 5 is 2, so dp of 1. And 2 is false, so include is false, exclude is also false, so this is false. 8 minus 5 is 3, dp of 1 and 3 is false, exclude is false, so this is false. 9 minus 5 is 4, and dp of 1 and 4 is false, and exclude is false, so false. 10 minus 11, 10 minus 5 is 5, dp of 1 and 5 is true, so this is true. 11 minus 5 is 6, dp of 1 and 6 is true, so this is true. Now, as soon as we got this true, that means we don't need to iterate the rest of the element. We are able to find a subset whose sum is 11, which is equal to our target, and we're going to return true. We don't need to fill the rest of this. So what is the time complexity of this one? It's O of T target N, right? This is our TC. What is our SC? O of Tn, right? Can we reduce this SC? If you look here, right? Target minus nums of I is the previous column. I minus 1 is the previous row. So we are looking at a previous row and the previous column in that previous row. So for populating this row, let me change column. So for populating this row, we are looking at this row element. So we need only 2 rows. So yes, we can do on the fly space optimization, and if we do that, our time complexity will be O of T because we only need these 2 rows. We don't need this N, right? So let's write the DP solution for this one and see if our time limit exceeded solution. Okay, so now that's been reset. Okay, so the first thing is we need to find the sum, which is integer sum is equal to find sum which takes nums public integer find sum integer array nums integer sum is equal to 0 for integer integer n is equal to num start length for I is equal to 0, I less than n, I plus plus. Sum plus is equal to nums of I and return the sum. Now, if sum modulo 2 is equal to 1, that is odd, return false, else target is equal to sum divided by 2, create a DP table, sizes, num start length and target plus 1. Iterate it row by row. Because row measure order is cache friendly. I have explained in a lot of my videos that we are doing target plus 1, so less than equal to target. Okay, so the first thing is if our target is equal to 0. This is our base case when target is equal to 0. We found a subset. So we're going to return true. We're going to set it to true in the DP table. Okay. And if our index is equal to 0, that is last element. Then we're going to check if nums, if that last element is equal to target. If that's the case, then we're going to return true. If that's not the case, then we're going to return, we are not returning, we are setting it. The DP of I j is equal to true. DP of I j is equal to false. And else we're gonna do include exclude, so boolean include is equal to false. Whatever target is j minus nums of I is greater than equal to 0, then only do this, otherwise don't do it. Include is always false. DP we are including it, so we need to decrement the index and we need to update the target, which will be target of nums of target minus nums of I. There is no target. The target is J is the target. So that's include and boolean exclude is equal to DP of I minus 1. We don't need to update the target, which will be J, and DP of I j is equal to include or with exclude. And that's our else condition. Now here, if I said, right, if this thing, so here, if I see true in this column, I stop and I return true, right? So if dp of target, the row is, the row could be any row, but then the target, which is 11, is equal to true, then I'm gonna return this will return true. We are done at that point. Okay, that closes the for loop. Another for loop, if nothing returns, we are not able to find it, we return false. And let's see our code is working or not. Oh, no, it's not integer, it's Boolean. And there you go, it's accepted. So that was our DP solution. We can also do on the fly space optimization, which I told you. For doing that, you know what? We don't need this. We only need 2 rows of size target. If you want to do it, we can do it. I'm going to do on the fly space optimization where the space complexity is O of t. And we need previous row and the current row. That's all we need. So Boolean previous row is equal to new Boolean, the size is target plus 1. Yes. And then the same iteration. Integer I is equal to 0. This is the outer loop. This is our outer loop. And before starting the inner loop, we need to initialize our current row, which is equal to new Boolean, same size. Our inner loop, 0 to target. Same code, nothing, no change. What was our base case? If target is equal to 0, we found a subset whose sum is 0. So our current row of that J is equal to true. Else if our index is equal to 0, then we're going to check that if our element at that index is equal to target, then we're going to set it to true. So current row of J is equal to true, else we're going to set it to false. And then the else condition include exclude. Boolean include is equal to false. And if our target, which is J minus nums of I, greater than equal to 0, then include is equal to previous row, right? I minus 1 our indexes. We are looking at a previous row. And then target is J minus nums of I. That's include. Exclude is the previous row, but our target is unchanged, which is J, and current row of that target is equal to include or exclude, right? So that's that. And I said that if the last column is true, then you return true. So if current row of that target is equal to true, return true. This closes two for loops and return false. So that's our space optimization. Let's see if it runs. Oh, it's a wrong answer. We made a mistake somewhere. Let's see what mistake we made. Oh, we didn't. Okay, so here. Okay, so once we complete this target for loop, right, we need to swap, right? Our previous row will become will have the values whatever in the current row. And then here this outside this target loop, we are reinitializing the current row. So we need to do that. We didn't do that. And there you go, it's accepted. So that was it. Very simple. Dynamic programming is very mechanical. Once you have your recursive code, it's very easy. Thank you so much for watching the video.